All right, so let's go ahead and go through these problems. So the first problem is we have to use a Venn diagram to explain why A intersection B complement is equal to A minus B. Okay, so let's go ahead and write the Venn diagram for A minus B first. So here is my universe, and here is my set A, and here is my set B. A minus B is going to be those elements in A which are not also in B. So it's going to look like this. All right, so now let's go ahead and look at A intersection B complement. All right, so this right here is B. So B complement is going to be the stuff which isn't B. So it's going to be everything but this inside, but this region right here. Okay, so now if I take A intersection with this region, I'm going to be left with this blacked out region right here. All right, so as you can see, this region right here is the same as this region right here. So this is how we can use a Venn diagram to explain how these are actually the same. All right, so one thing to be careful about, using a Venn diagram is not a formal proof. Okay, I'm going to repeat that again. Using a Venn diagram is not a formal proof, but it can be used to visually gain intuition as to whether or not two things are the same. Okay, next question. So we want to find examples of sets A and B such that their union, A union B, is equal to their intersection, A intersection B. So let's go ahead and kind of draw out what the union and intersection looks like again with a Venn diagram. The union of two sets, it looks like this. The intersection of two sets is the part that's shared in common between these two. So it looks like this. So the union is going to equal the intersection if the sets completely overlap with each other. So for example, if set A looks like this and set B also looks like this, then both their union and intersection is going to be like this. So that will help us come up with a very simple example. So let A be the set 1 and let B be the set 1. Then we can notice that A intersection B is equal to 1 and A union B is also equal to 1. All right, here's the last problem. Explain why there is no set A which satisfies A equals the set of elements containing 2 and the cardinality of A. Okay, so here's my thought process on this. This might not be very easy for everybody to see right away, but that's okay. So first of all, let's talk about what the cardinality of a set is. The cardinality of a set A, of a finite set in particular, is the number of elements in the set. Of course, for sets with infinite numbers of elements, this is a little bit more of a complicated concept, but that is something which we're going to leave for later. All right, so here's what's basically going to happen. So A is going to contain, is going to look like this. It's going to look like 2 comma x, right? Because it contains 2 elements. Okay, and x is particularly equal to the cardinality of A. Okay, so x is equal to the cardinality of A. So there's like really 2 cases to consider, right? So if x is equal to 2, then the cardinality of A is going to be equal to 1. Why is that the case? Because A, in that case, would just be this set, but this is just 2. All right, otherwise, the cardinality of A is going to equal to 2. Is going to equal to 2. So we can look at both of these cases and we can actually see that none of them work. So for example, in this top case right here, if x is equal to 2, then that wouldn't make sense. Why wouldn't that make sense? Because then the set should be 2 and then the cardinality of A. But if x is 2, then the cardinality of A is 1. This is basically a contradiction. Otherwise, the cardinality of A must be 2 because there are actually 2 elements in the set. However, if the cardinality of A was 2, then there would only be 1 element in the set. So this also leads to a contradiction. So as we can see, no matter what, we are going to be led to a contradiction. So these are a few examples of problems which you might see in set theory. By working through a lot more examples, through a lot more like different questions on your own, you'll be able to develop this intuition needed to solve more difficult problems and to understand the important concepts. All right, so that's going to be the end of this video. I will see you all in the next video.